We have discussed about the equation of an ellipse, correct? Now there is a very important parameter which defines and which differentiates all the conic sections. Okay, and that particular parameter we call it as the eccentricity. Eccentricity. Now what exactly is the meaning of eccentricity? See, eccentricity is the ratio of the distance of the the focus, whatever you have, to the vertex, whatever we have the distance from the center. In the sense, for an ellipse, that too, see, you have the x-axis, y-axis like this, and you're going to have an ellipse. So assume that the ellipse, it looks something like this. Just take an example. So when you take an example of an ellipse like this is the focus F, this is the one of the vertices, isn't it? And you can call this a center. Again, I'm telling you, depending on different books, you can change the name, the center, the vertex, a lot of things. Okay. So from the origin, this distance, see, assume this is A. The focus is at C comma 0, isn't it? And A is at A comma 0. Remember, semi-major axis, this one. Now, the eccentricity is defined as the ratio of the focal distance to the vertex distance. That means E is equal to C divided by A. Or you can write C is equal to AE. This is 1, and this is the formula what we use for eccentricity. Now, depending on the eccentricity, the graph in the sense the conical section whatever we have, that can be differentiated. For example, suppose if eccentricity is 0, then the figure is a circle. Okay, suppose if eccentricity is 1, then it's a parabola. Suppose if eccentricity is less than 1 but more than 0, between that, then it's an ellipse. So likewise, I'll just write down what is what. Like if this is the eccentricity, what it's going to denote. All right, we'll make a table. All right, suppose, so this is the value. So we'll say this is the value of E. And say here we can say that this is the curve. What type of curve we are going to get? We'll make a nice table. The first one, suppose E value is equal to 0, then it is a circle. Alright. Suppose if E value is between 0 and 1, more than 0, less than 1, then the figure is going to be an ellipse. Another type of a conic section. Suppose if E value is 1, then it's a parabola. Suppose if E is greater than 1, then this is a hyperbola. So, like this, we can figure out based on the eccentricity, and eccentricity is given by what? E is equal to C divided by A. This is the formula for eccentricity. So, based on the eccentricity, we have different types of conical sections, whereas for an ellipse, E is equal to C by A. So, based on this, we'll understand what is the length of the latus rectum for an ellipse in the next video.